All right, this section 3-3 is all about interpreting graphs and tables. So this is about being able to apply data that's found in either a graph or a table to a practical situation, or taking a practical situation and then being able to interpret that so that it is in a data table or a graph. So let's go ahead and start with example number 1. We've got the speed of 3 snowboarders in miles per hour at given times during the race. And then it asks us to tell which snowboarder corresponds to each situation. So snowboarder 1, let's just look at the table first. What I'd always advise you guys to do is kind of acquaint yourself with what you've been given. Right here, that very first row tells us the time in seconds. So that first column means, okay, at 6 seconds, at 12 seconds, at 18 seconds, at 24, and then at 30. The next rows are the different snowboarders. The 15, 18, 22, 19, and all the other numbers, it says up in the first little paragraph that that's miles per hour. So what that would mean is, like, for that very first cell, it says 15. That means that at 6 seconds, the snowboarder 1 was going 15 miles per hour. Then he's going 18 miles per hour, and so on. So hopefully you'll get yourself acquainted with the table, so then once you start doing the rest of the question, you'll understand where to go from there. Okay, so let's look at A. It says Jordan gets off to a good start and continues through the course, picking up speed. So it looks like he is going to be increasing the entire time. So let's look through it. Here we start off at 15. So if snowboarder 1 is Jordan, we'll try to figure that out. So he starts off at 15. He increases speed. He increases more, but he doesn't gain speed right there. So we can't say that Jordan is snowboarder 1. So let's look at 2. He starts off at 17. He increases speed, but something happened and he stops. He's not moving at all at 18 seconds. So definitely Jordan is not snowboarder 2. So let's check 3. He starts off at 16. He increases to 19. He increases more to 22, to 25, and to 26. So at that point we can say for sure that Jordan is our snowboarder number 2. Snowboarder number 3. Okay, so let's do the next one. B says Ethan gets off to a good start and picks up speed. Toward the end of the race, he nearly falls. He rights himself and finishes the race, reaching his greatest speed. Okay, so let's look at the ones that we have left. Also checking, we can double check and make sure it's not 3, but let's look at the other 2. So if Ethan is snowboarder number 1, let's see if it fits. So it says he starts off at a good pace and he picks up speed. That is true, so that worked. Toward the end of the race, so he's picking up speed. Toward the end of the race, look at what happens from here to here. Something happened. Could it possibly be that he almost fell? So he slowed down, but he corrected himself and ended up going faster than he was at any time during the race before. Looks like snowboarder 1 is Ethan. Okay, so let's go on example C and see if it fits the other one. So Xavier gets off to a good start, but falls around the middle of the race. I think we know which one that is. Looks like he gets off to a good start. He's going faster, but what happens when you fall? You're going to stop. You're not going to be moving at all for at least a little bit, and then he gets back up and then continues on to the finish line. So definitely Xavier is our snowboarder number 2. Let's go on to the next part. Now what we're going to do is we're going to look at a graph compared to those different scenarios. So I have my front page really small on the side. Hopefully you can see it. You're welcome to flip back over if you need to. Let's go, instead of looking at the table, let's look at the examples and the practical descriptions and compare them to the graphs and see which one fits. So on A, Jordan gets off to a good start and continues through the course picking up speed. If he's picking up speed, notice here all of these graphs are time versus speed. As time goes on for Jordan, speed increases. So let's look at this. As time goes on, look at all along the way, speed is generally increasing. That seems about right. So let's look at graph 2. This is sort of still right. We've got really good start. He is increasing generally, but not as consistently as the first one. And then the third one, it looks like he's gaining speed, but at some point he loses speed entirely and goes back down to 0. So that's definitely not Jordan. I think our best pick for graph number 1 would be that it is Jordan. So snowboarder 1 would be Jordan. And then the next one, Ethan gets off to a good start and picks up speed. Toward the end of the race, he nearly falls. So here, he's picking up speed, but at some point, he slows down. Look at this graph right here. He's picking up speed, but right here, it looks like he's not picking up speed anymore. He's actually maybe slowing down a little bit, but definitely not getting faster. So I would say that Ethan is snowboarder number 2. Goes with graph number 2. And then the last one, Xavier, he's the guy that fell, and you can see that very clearly on the graph right here. At one point, even though he's gaining speed along the way, at one point he completely stops, so this has to be Xavier. Okay, so let's go on to the next. Alright, so example 3 says creating a graph of a situation. The flight of a commercial airliner can be modeled with a graph. Create a graph that models the flight of a commercial airliner. Okay, now usually in Algebra 1, you're going to want to plot your x as your first column information, your y as your second. So here we're going to put time on our x-axis and altitude on our y-axis. Now again, we want to make sure that we can see our data pretty well. So let's look at how we need to label our graph. We need to go from 0 to 90. So I'm going to just kind of feel my way through and see how many lines I have and see what my best bet is as far as labeling my axes. So here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So probably a good way to label it would be by 10. So we're going to do 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. That's really small. Okay, now let's look at our y-axis. We need to go from 0 to 30,000. So probably what I would do here is I would say 30,000 is up here, and I might just cut it in half. So if 30,000 is right here, 15,000, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 15,000 is going to be right here. And now I can plot my data at least as a good estimate. So let's go ahead and do our data points. I'm going to change my color. Okay, so at 0 times 0, the altitude is 0. At time 10, we're at 10,000 feet. So 10,000 feet is going to be about right there. At 20, we're going to be at about 20,000 feet. Okay, at 30, we're going to be at 30,000 feet. At 60, so we're way over here now, at 60 we're going to be at 30,000 feet. At 70 we're going back down to 20. At 80 we're going back to 10. Oops. Let me erase that one, I did that wrong. And at 90 we're going back to ground. So there we've got the flight of a commercial airliner. And you've got your points plotted, and you've gone from a table to a graph that can be read, and you can kind of see the flight path graphically. All right, hopefully that was easy. You guys have a good rest of your day, and I'll see you when I get back.
Made with Doodlecast Pro.